So for number 2, we have a continuous variable x, and its values are anything between 1 and 5. So x is going to be, again, oh, that pencil keeps showing up. X is again going to be quantitative, but this time it's not discrete, it's continuous. So I'm measuring something. And its distribution is any value between 1 and 5, and it takes on any value between 1 and 5 with equal probability. This is a density curve. The name of the distribution that we are seeing here is called a uniform distribution, so the answer to 1A is uniform. What's the equation for this distribution? So for this density curve, the density curve, you notice, is a line segment. It's a horizontal line segment, and the y value is always 0.25. So the equation for the density curve is y equals 1/4 or 0.25. Notice if it's uniform, you can take 1 over the last value, the maximum value, which is, I'll call it b, minus a. And in this case, the maximum value was 5. So 5, and the minimum value was 1. So 1 over 5 minus 1, so again, 1/4. So that is the equation of the density curve. We can find probability. What's the total area under the distribution curve? So the total area underneath this density curve is 1. It's always 1. Use this distribution to find the probability that x is less than 2.56 and show your work. So if I have this density curve, so instead of a histogram, this is one bar. It takes on infinite number of values between 1 and 5. So there's an infinite number of possibilities, 2, 3, 4. So 2.56, that's 3, that's 2, so roughly 2.56. And we want to be, did I say less than or at least? That's at least. At least, x is at least 2.56. So I'm going to shade all of the area underneath the density curve, y equals 1 over 4, for any value of x in between 2.56 and 5. So I have a rectangle. The area of the rectangle is the same as my probability that the x value is at least 2.56, but no more than 5. It can't be more than 5 because the probability is 0. And we get area is length. Let's see. 5 minus 2.56 would be the length. So 5 minus 2.56 is the length of the rectangle. 5 minus 2.56. And the height, well, the height of the curve, it went up to 0.25, which is the same thing as 1/4. So the height of the rectangle is 1/4. So I'll multiply those two quantities together. 2.56, oh, clear. 5 minus 2.56 times 0.25. Make sure I've got that there. And I get 0.61. Okay. Does that make sense? Let's see. The halfway mark between 1 and 5 would be about 3. And so we're over the 3, so that would be 0.5, sorry. And then we get this little bit of wedge, a little rectangle here after 0.5. So having a probability of 0.61 does make sense. What's the median? Median meaning half of the observations above and half below. So 50%, or the probability is 0.5 for greater and 0.5 for less. The halfway mark, so average 5 plus 1 is 6 divided by 2 is 3. So the median here, the quantity with 50% of the area above, 50% below, the median is going to be the quantity 3. And I did that by taking 5 plus 1 and divided it by 2. Notice to find the length, I said 5 minus 1 was the distance between the two. If I want the midpoint between 5 and 1 is the average of those two, which is 3. All right, is the mean of the distribution, circle 1, we want less than, greater than, or equal to. So I know if the mean is equal to the median, that happens when I have a symmetric distribution, and this looks very symmetric. It isn't skewed to the right, so the mean isn't drug over to the right. It's not going to be greater than the median. I don't have a skewed left distribution, so the mean isn't going to be smaller. The mean and the median are going to be exactly the same, because if you have symmetry, then you're going to have the mean to equal the median. Okay.